Hello everyone, welcome to Miss Lee's class. Today we're going to learn how to find squares, and square roots of whole numbers using prime factorizations. Okay? Alright everyone, what are prime numbers? Prime numbers are the numbers that have exactly two factors, 1 and itself. So for example, 2 is a prime number because it has two factors, 1 and 2. And 3 is a prime number because it has two factors, 1 and 3. What about 4? Is 4 a prime number? No, 4 has three factors, 1, 2, and 4. So 4 is not a prime number. 5 is a prime number. 6 is a prime number? It has 1, 2, 3, and 6. 4 factors. So it's not a prime number. So 7 is a prime number. So there's so many prime numbers, infinitely many prime numbers, okay? So prime factorizations. So prime factorization is basically finding prime factors, prime number factors, okay? So for example, you have 12 here. And what you do is find the product that makes 12, which is 3 and 4. So when you multiply 3 and 4, it becomes 12. 3 is a prime number, so you cannot go any further, but 4 is not a prime number. So you find the prime factors, 2 and 2. So this is a prime factorization, and you circle all the prime numbers, and you can say 12 is 3 times 2 times 2. Or using a power, you can say 3 times 2 squared, okay? There's another way of making a prime factor tree. This is called factor tree. So we can find a factor other than 3 and 4. So for example, we can find 6 and 2. Is that right? And 2 is a prime number. So we are going to find a product that makes 6. And that is 3 and 2. So we have a same combination again, right? So 3, 2, 2. So 3, 2, 2. 3 times 2 times 2. So that is, so you can just, the order does not really matter. You can say 2 squared times 3. So either way, you get the same answer. Right, everyone? Okay. Now we're going to learn how to find the squares using the prime factorization. So we're going to find the prime factorization of 24, 36, and 81. So I want you to pause the video and find the prime factorization of 24, 36, and 81. Go ahead, everyone. All right. Let's do it together. 24. 24 becomes 6 times 4. And 6 becomes 3 times 2. And 4 becomes 2 times 2. So you circle prime numbers. And 24 is 2 times 2 times 2 times 3. Or you can say 2 cubed times 3. Because you multiply 2 3 times. What about 36? 36 becomes 6 times 6. 6 is 3 times 2 and 3 times 2. So you have 2 2's and 2 3's. So we say 36 is 2 squared times 3 squared. All right? And 81. 81 becomes 9 and 9. 3 and 3 and 3 and 3. It has 81 has 4 3's. So 3 to the power of 4. Okay? And this one you can also list it 2 times 2, 3 times 3, and 2 squared, 3 squared. Okay, so we found the prime factorizations. Okay? And now we're going to figure out which of the numbers is a perfect square. Explain. So what you're going to do is, if you look at 24, how many 3's do you have? Only 1. How many 2's do you have? 3. So what you're going to do is you're going to draw 2 brackets, and you're going to split those numbers into those brackets. Try to make it equally. So 2 and 2. And you put 2 here. You should put 2 here, but there's no more 2 left. You can only put 3 here. So you cannot equally split those 4 numbers. Therefore, 24 is not a perfect square. But what about 36? 2 brackets. You have 2 3's and 2 2's. So let's put 2 and 2. And let's put 3 and 3. So you found equal groups. So 2 times 3 is a 6. 2 times 3 is a 6. So 36 is 6 squared. So therefore, 36 is a perfect square. And 81, same thing. 2 groups, 3 and 3, 3 and 3. You could equally split those numbers into 2 groups. So 3 times 3 is 9. 3 times 3 is 9. So 81 is 9 squared. Therefore, 81 is a perfect square. Right? Okay, so right, 36 is 6 squared. 81 is 9 squared. Okay, for each number that is a perfect square, draw the square and label its side length. So using a diagram, we can explain the squares and square roots. So say the area of the square is 36 and the area of the square is 81. So what is the length of the square? You can find this by taking a square root of it, root 36, which is 6. Okay, so the side length is 6. And 81, what is the side length of this? That is square root of 81. That is same as 9. Okay? Alright, everyone. Let's move on. Example 2. We know the area of this. This is a square. We know the area of this is 144 square centimeter. How do you find the side length? So I want you to pause the video and think about it. Alright, everyone. The side length is the square root of 144. That is square root of 12 squared. So when you have a square root and the exponent 2, you can cancel it. The answer is 12 centimeter. So you know 12 times 12 is 144, right? So the area of the square is 144 and the side length is 12 centimeter. All right? Okay, let's move on. Square of 4 versus square root of 4. Some students get confused with those two. So they're different meanings. Square of 4. That means you have to repeat multiplying 4 twice, which is 4 squared. That is 4 times 4, 16. Square root of 4. That's you have to think about what number you have to repeat multiplying to get 4. Okay. 4 is the same as 2 squared. Then we can cancel cancel the square root and the exponent, 2. And the answer becomes 2. So square root of 4 is root 4. Okay? And the answer, if you evaluate it, that is 2. Okay? Don't get confused. Square root of 4. Repeat multiplying 4 twice. Square root of 4, that is root 4, and that is 2. Okay, so find the square of each number and find the square root of each number. Number 1, the square is 9 squared. What is this? 81. Number 2, square root of 9. What is this? That is 3 squared, and you cancel, then the leftover is 3. So root 9 is 3. Okay? 16. 16 squared is, if you evaluate it using your calculator, that becomes 256. Square root of 16. What is this, everyone? That is 4. Because 16 is 4 squared. And we can cancel. And the answer is 4. Make sense, everyone? And let's move on. We're also going to learn about cubes and cube roots. So to cube a number, just use it in a multiplication 3 times. So basically you repeat multiplying that number 3 times. So 2 cubed means you multiply 2 3 times. That becomes 8. Cube root of a number is a special value that when used in a multiplication 3 times gives that number. So 3 cube root of 8. That means you have to think about one number you have to multiply 3 times to get 8. So that is 2 cubed. So cube root and the exponent 3, you can cancel it. The leftover is 2, right? So cube root and cubing is exactly the opposite meaning. So 3 cubed is 27. Cube root of 27 is 3. Alright, everyone? Example 4. Find the cube of each number, then find the cube root of each number. So here's a typo. I want you to fix it to 64. Alright? So number 1, the cube of each number. So you have to cube it. Cube of 64. So using your calculator, evaluate it. Number 2, cube root of each number. Again, you have to think about one number you have to multiply 3 times to make 64. Okay? Okay, number 1, let's use your calculator. So what you're going to do is 64. So your calculator may have this sign. Okay, do you see this? And you're going to hit this to the power of 3. If you don't have this, you may have this extra power of y button. Or y to the power of x button. So you can just use either x to the power of y or y to the power of x to put exponent into your calculator. Okay? So my calculator has this button. So 64 to the power of 3 is 262,144. Right? What about cube root of 64? You don't really need a calculator for this. So cube root of 64 is 4 times 4 times 4. 4 cubed. And now you can cancel this. And the answer is 4. Next, B, I want you to pause the video and find the answer. You may use your calculator. Go ahead, everyone. All right, let's do it together. Number 1, 125 cubed. Let's use your calculator. 125 to the power of 3. So you have 1,953,125. Number 2, cube root of 125. What number do you have to multiply 3 times to get 125? That is 5. 5 cubed. So you can cancel the exponent and the cube root, and the answer is 5. Alright, everyone, there are more practice questions. So those are squaring a number, square root of a number, cube root of a number, and taking a cube root of a number. So I want you to pause the video and finish those questions. I'm gonna show you guys the answers soon. So go ahead, everyone. I want you to try these questions by yourself first. Alright, everyone, look at the screen. These are the answers of the question. So I want you to check the answers. Alright, everyone, hope you guys understood today's lesson. Now I want you to start doing your homework. Thanks for watching, everyone. Bye-bye.